In the beginning of the history of experimental observation or any other kind of observation on scientific things, it's intuition, which is really based on just experience with everyday objects, that suggests reasonable explanations for things. But as we try to widen and make more consistent our description of what we see, as it gets wider and wider and we see a greater range of phenomena, the explanations become what we call laws instead of simple explanations. But the one important odd characteristic is that they often seem to become more and more unreasonable, more and more intuitively far from obvious. To take an example is the relativity theory, in which, for instance, the proposition is that if you think that two things occur at the same time, that's just a subjective opinion. Someone else could conclude that those two events, one was before the other, and that simultaneity is merely a subjective impression. Now, there's no reason why this should be otherwise, really. The things of the direct everyday experience involve large numbers of particles, or involve things moving very slowly, or involve other conditions that are very special and represent, in fact, a very limited experience with nature. It's a small section only that one gets of natural phenomena from a direct experience. It's only through the refined measurements and careful experimentation that we can get a wider vision. And then we see unexpected things. We see things that are far from what we would guess. We see things that are very far from what we could have imagined. And so our imagination is stretched to the utmost, not as in fiction to imagine things which aren't really there, but our imagination is stretched to the utmost just to comprehend those things which are there. And it's this kind of a situation that I want to talk about tonight. Start, for instance, with the history of light. At first, light was seen to behave, it would appear to behave very much like a rain of particles, of corpuscles, like rain. Bullets from a gun, same idea. Then with further research, it was clear that it was not right, but that light actually behaved like waves, like water waves, for instance. And then in the 20th century, on further research, it appeared that light actually behaved in many ways, again, like particles. In the photoelectric effect, you could count these particles, they're called photons now, and so forth. Again, electrons, when they were first discovered, behaved exactly like particles, bullets, very simple. Further research showed, in electron diffraction experiments and so on, that they behave like waves. And as time went on, there was a growing confusion in the question of how the things really behave, the waves or particles or waves, because everything looked like both. Now, this growing confusion was resolved in 1925 or 26 with the advent of the correct equations for quantum mechanics. And now we know how the particles, how the electrons, and how light behave. But what can I call it? I can say they behave like a particle wave, or they behave in typical quantum mechanical manner. There isn't any word for it. If I say they behave like particles, they give the wrong impression. If I say they behave like waves, they behave in their own inimitable way, which technically could be called the quantum mechanical way. They behave in a way that is like nothing that you have ever seen before. Your experience with things that you have seen before is inadequate, is incomplete. The behavior of things on a very tiny scale is simply different. They do not behave just like particles. They do not behave just like waves. Atoms do not behave like weights hanging on a spring and oscillating, nor do they behave like miniature representations of the solar system with little planets going around in orbits. Nor does it appear to be somewhat like a cloud or fog of some sort surrounding the nucleus. It behaves like nothing that you've seen before. Well, there's one simplification. At least electrons behave exactly the same in this respect as photons. That is, they're both screwy, but in exactly the same way. How they behave